Hey everyone, looking at class 4.3, we're going to work on breaking vectors into components, something we've done before. We're just focusing on doing it for velocity vectors specifically. So try to do this on your own, break this vector into x and y components like we did on the last test. You can pause the video and try it out, and then I'll go through it in a second. So we have our x component and we have our y component. We would call this ax, or actually, excuse me, vy, and we'll call this one here vx. To solve for vy, we know that vy equals v times sine theta. So vy is equal to 15 meters per second times the sine of 28 degrees. Throw it out in our calculator. And we get about 7.04. So vy equals 7.04 meters per second. Now what that tells us is how quickly this object is moving upward initially. Vx is going to tell us how far is this, or how quickly is this object moving horizontally initially. Looks like we have 13.2. So that's how quickly this object is moving horizontally. All right, so there might be another way you would see this on an exam, so I just want you to be aware of it. Notice how when I have my components, they are tip to tail there, and it kind of makes a nice right triangle. You won't always see it that way. One way you might see this drawn, so let's draw it a couple different ways actually. The way I showed it here is a common way to draw it. 13.2 meters per second, y component of 7.04 meters per second. But you might also see something like this. The horizontal component of 13.2 meters per second, and the vertical component actually drawn from here of 7.04 meters per second. So just be aware that you might see it drawn either way, but they both represent the same thing. Remember, for the second way we just drew this, we can slide one of those two vectors so that we can add them tip to tail. So try this one out on your own and just think about where you would put these values in the XY charts, because we are going to use those for angled projectiles, which is what we're going to get into next class. So after you give it a try on your own, I'll do it right now. All right, so getting Vx equals, I'm just going to skip the equation here, 23.6 times cosine of 56 degrees. Run that in our calculator. We get 13.2. So the horizontal component of the velocity is 13.2 meters per second. Getting the y component, 23.6 times the sine of 56. And we get 19.6 here for Vy. So these are both velocity values, so they're definitely going to go into our velocity rows. But think, are these the initial or final velocities? So in both these cases, they are initial velocities because it's initially launched with that velocity. And those values might change over time. We actually know that the horizontal velocity will never change because there's no horizontal acceleration, but the vertical velocity will change over time. So we're just going to put them both in the initial velocities. So this would be 19.6 meters per second because that is our initial velocity in the y direction. And this will be 13.2 meters per second because that's our initial velocity in the x direction, which actually won't change. So this one's a little bit different. It says sometimes we're given a component and has to find the magnitude of the initial velocity. So instead of being given the hypotenuse, we're going to be given one of the components. So a baseball is thrown at an angle of 40 degrees above the horizontal. The horizontal component of the baseball's velocity is 12 meters per second. What is the magnitude of the ball's initial velocity? So that's looking for the hypotenuse. So let's sketch it. This is 40 degrees. This is our unknown. The horizontal component is 12. That's right here, 12 meters per second. The vertical component is unknown. We also just don't need it. So think about how we would solve for the hypotenuse now. So before we were given the hypotenuse and we found a component, now we're given a component, asked to find the hypotenuse. It's actually the same equation we've been using the whole time. So we have the equation Vx equals V cosine theta. Vx, I'm going to plug in my x component now because now I have this value. So that's going to be 12 meters per second. V is my unknown. And then we have cosine of 40 degrees. We have to isolate V, so I divide both sides by cosine 40. So 12 divided by cosine 40 degrees will give me my hypotenuse. So the hypotenuse should definitely come out to be greater than 12. So that's something you can keep in mind to think about, did I do this correctly? All right, so let's see. Cosine of 40. I'm getting about 15.7. And that makes sense because it is larger than one of the legs of the triangle. The hypotenuse has to be the longest side of that right triangle. All right, so here's some practice questions. Again, you should be trying these before I do them. I'm not even going to show a picture here. I'm just going to sketch them out. Or just do the math, rather. So to get the horizontal component, Vx equals V cosine theta. Vx equals 15 times cosine of 60 degrees. So I know that Vx is going to be, I believe cosine 60 is 1/2, so it's going to be 7.5 meters per second. So that's going to be the horizontal component. The vertical component is going to be V times sine theta, 15 sine of 60 degrees. Throw that in our calculator. We get almost exactly 13. This question is almost identical. Numbers are just a little different. So for the x component, we have Vx equals 100 times cosine 15 degrees. We get about 96.6 meters per second. To get the y component, Vy comes out to be 25.9 meters per second. So one really good way to check your work here to see if you did these correctly would be to do the Pythagorean theorem, like 96.6 squared plus 25.9 squared, and see if it comes out to be 100 squared. It should work out just about right. Now, it won't be exact because our answers rather, are slightly rounded, but it should come out to be very close. So that's breaking vectors into components, and that's everything you need to do or learn to start doing angled projectiles, which we'll do next class. See you next time.